All right, on the next page, there's going to be like this VR thing. I think you should be able to control it with the mouse and the arrow keys as well. You're going to be inside of a skate park. I just want you to think about the different kinds of force and motion things that we've learned about as you go through this skate park. It's good to know that we're recording our lesson today, and people at home get to listen to these comments that I have to listen to on a daily basis. So again, kind of take a look around. Poser. All right, so let's look up here. Some of us are being a little inappropriate with this VR tour. I can see through your computers, and then some of the comments are not very kind. What are some of the things that you have seen? And if you tell me the person to focus on, I'll try to find them. AJ. Well, that's great, but what does that have to do with force and motion? So, yeah, when I look at this, I start thinking about Newton's 3 laws, right? Now, I mean, I know that the skateboard and the skateboarder are both very happy just to sit there until they start moving. And once they start moving, they're very happy to continue moving. I know that I can think about other parts of Newton's laws because for every action, there's an equal and opposite reaction. If you've ever been on a skateboard, if you barely push down, it's not going to come off of the ground very high. You have to put a lot of force into that. I know that you can look at Newton's second law, that skateboards do not have a lot of mass. So it doesn't take as much force. If the skateboard weighed 5 times the amount that it does and had more mass, it would be really hard to do that. I do see friction on the top of that. I know that he eventually came to a stop. That's friction. I see that when the skateboard went up in the air, gravity's pulling him back down. He doesn't just keep going up in the air. So that's good. That's some things that we see. Yes, ma'am. So, yeah, I think that the concrete, it definitely has friction. I don't know if it has a lot. They get moving pretty good on that smooth concrete. It definitely has some friction. It's better than a gravel parking lot, but it's not an ice skating rink, right? I think they probably have just the right amount of friction for them to go on. Absolutely. Braxton. Do you think this guy fell? This guy? Yeah. So, yeah, he obviously maybe not enough friction on the skateboard to keep him off, or if he's on the skateboard and he moved off of it, what kind of forces were acting on him, because there was movement. But there's 2 forces we talked about. One, there's no movement, and then one, there's movement. Yeah, there's inertia involved. That would be unbalanced force, right? If he gets moved off of the skateboard, there was an unbalanced force, whereas if there's balanced forces, there's no movement. So, yeah, I think that's good. We've had 5 minutes now almost of looking through that, so we'll continue to move on. Not going to do that page. Going to keep on skipping. Not going to do that either. All right, so in looking at a regular DST question, just, Sam's mom went 120 miles in 3 hours. How fast was she driving? Most of us in all 3 classes are doing okay. Yesterday, when we started doing some of the multi-step problems, we had a few issues here and there. I've got some folks that we probably need to work a little bit more. Today, we're going to take a look at what I would consider the third tier, maybe the hardest of the questions, because they require even more of you. Some of them are 4 and 5 step problems. And so we'll take a look at some of these. You can do this in your notebook if you want to. If you need to get a scrap sheet of paper, I'll pause the video and let you do that real quick. I'm going to do the first one to kind of show you what these look like, and then I'll let you guys work on them, and then we'll solve them together. Greg's family is planning a trip and want to choose the method of transportation that travels with the most speed. Which should Greg's family choose? And then it gives me 4 answers. So I guess the annoying part for a lot of us is, oh, great, they're asking me to solve for all 4 answers and tell them which one's the fastest. And the answer to that is, yeah. So like I said, some of these are going to be like super multi-step. Well, it's very easy because now all I have to do is figure out these. So a bus traveling 60 kilometers every 2 hours. Here's the bus, distance, speed, and time. 60 kilometers every 2 hours. 60 divided by 2 is 30. So this one's 130 kilometers an hour. I do the next one. Car traveling 60 kilometers every 4 hours. All right, so 60 kilometers, 4 hours, 60 divided by 4 is 15. Train, 120 every 4. 120 divided by 4 is 30. All right, so I'm going to assume this last one is the fastest because I've got 2 tied at 30 and 1 at 15, but I'm going to solve it anyway. Now I've got 120 divided by 2, which is 60. You probably could have assumed that a plane is faster than a train, a car, or a bus, right? But don't just do that because sometimes they're going to change those around. So again, quadruple step problem, but the math inside of the problems are very easy. So again, when you have these multi-step, this is a quadruple step problem. We had to solve this one, which got us 30 because 60 divided by 2 is 30. We solved this one. 60 divided by 4 is 15. I solved this one. 120 divided by 4 is 30. And then a plane is going 120 every 2 hours. 120 divided by 2 is 60. And I got the correct answer. Here is the next one I want you to try on your own. Object Y traveled 700 meters in 10 seconds. Object Z traveled 500 meters in 10 seconds. How much faster was object Y than object Z? All right, Hayes, I know, I think most of us kind of see this, right? So here's object Y. Here's my DST triangle. Where does 700 meters go? Distance in 10 seconds. 700 divided by 10 is 70. Okay? And so now I have object Z. I don't know, that's like a DST candy corn. I don't know what that is. 500 meters in 10 seconds. 500 divided by 10 is 50. Now, if they were smart, they would have put 70 and 50 as 2 of the answers in there. They did not. I would have done that. But I'm not done. What do I need to do? Because it says, how much faster is Y than Z? What do I do with the 2 numbers? So you say 70 minus 50. Terrible, terrible handwriting there, but that's fine. And you get B. All right. So let's think about this. Jose's driving to New York. I see that I can do some DST work inside of here. He traveled 100 miles in the first hour and 20 miles in the last hour. What can I say about Jose's drive? Okay, did he drive less than 120 miles? Well, no, he drove 120 miles. So that's not it. Now, these next 2, he drove faster in the first hour or slower in the first hour. One of those cannot be true. So in the first hour, 100 miles, that's 100 miles an hour. I don't need to do a DST triangle, right? So for hour 1 It's 100 miles an hour. I'm just going to put this very quickly, writing with the things that 20 miles in the last hour. So hour number 2, he's going 20 miles an hour. Was he going faster or slower in the first hour? So I know it's not this one. I know it's not this one. Jose drove the same speed. The answer is B. Do you see how you can reason your way through that one without really... If you draw the triangles out, nobody's going to yell at you, but I didn't need to draw it on those. Let's check out our next question. Mike and Rachel ride their bikes 1 mile to the park and then ride their bikes 1 mile to the store. It takes them longer to get to the park than it takes them to get to the store. What can be concluded? Jonah, what's the best reasoning in this? So they rode their bikes 1 mile to the park and 1 mile to the store. It took them longer to get to the park. So did they bike faster to the park? If it took them longer to get to the park. So that can't be the answer. Did they bike faster to the store? I mean, it says it takes them longer to get to the store, so it sounds like that could be a possible answer. I'm going to check it. Mike and Rachel went a different way to the park and the store. I have no idea. Mike and Rachel bike the same speed. Well, that can't be true because it took them longer to get to one place than the other. The only reasonable answer is B. Again, is it a speed, distance, and time question? Yes. Do you have to draw a DST every one of those? No, not necessarily. Sarah ran 250 meters in 30 seconds on Monday. On Tuesday, she ran 300 meters in 30 seconds. How much faster was her speed on Monday than on Tuesday? Do I need to draw DST triangles this time? I do. All right. Again, this is where I get a little frustrated with the whole thing that we can't have calculators on the benchmarks and the EOGs. Because if they give you a question like this, I just don't think that we're quite ready for that. $250 meters in 30 seconds. Now, 250 divided by 30, for those of us that worked it out, ends up being 8.333333. It just continues, right? We'll just call that 8.3. I'll put a bar over it because I know it's repeating. This second one is fairly easy. Like this is what the question should be if we're not going to give you a calculator. 330 seconds. Well, that's. I mean, I don't even have to really 300 divided by 30 equals 10. What is the difference between 1.7? 10 minus 8.3 is 1.7. Again, now you understand. It's like, okay, this might be a little bit tougher if we're not going to be giving calculators. I'll be interested to see what the benchmark looks like and kind of looking towards the EOGs, and we'll see if there's a whole bunch of these. If there's a whole bunch of these, then I'm going to be sending that to the people that need to see it here. So if Kyle and John are taking a road trip, the car travels a greater distance during the second hour than the first hour. What can be concluded? Is the car moving at a constant speed? No, because then it would take the same amount of time, so that can't be the answer. The car is moving faster during the first hour. So it says the car travels a greater distance during the second hour than the first hour. Can't be B. The car is moving faster during the second hour than the first hour. Maybe. I'm going to put it, just to come back. The car is moving in different directions. Does it say anything about the directions? So it has to be C. All right. Not going to make it to another question, which is fine. It's just review questions. Smash the like button, subscribe, click the notification bell.